We will discuss some important terms. First one is atomic number. Okay, atomic number is denoted as capital Z, and any atom, its atomic number is equals to the number of protons in the nucleus of an atom, as well as this is equals to number of electrons in the neutral atom. Suppose for example, if I'll write nitrogen. Okay, nitrogen symbol is in, its atomic number is 7. Okay, so if its atomic number, we know that atomic number equals number of electrons equals number of proton. So its number of electron is 7, number of proton is 7, and atomic number is also equals to 7 because it is a neutral atom. Is all are same, but for cation and anion it is different. Okay, next term is mass number. Mass number is denoted as capital A. Okay, and we know that mass number is equals to number of protons plus number of neutrons. Okay, and they collectively, the protons and neutrons are collectively known as your nucleons. Okay, if A is equals to n plus p, that is number of neutrons plus number of protons, then number of neutrons is equals to what? Mass number minus number of protons. Will represent an atom. If X is an element or an atom, then in the left hand side lower corner the Z represents its atomic number, and the upper corner A represents the mass number. Okay, another term is isotopes. What do you mean by isotopes? The atoms of the same elements having same atomic number but different atomic masses are called isotopes. Okay, hydrogen has 3 isotopic forms. One is 1H1, that is protium, 1H2 deuterium, and 1H3 is tritium. Okay, now in all the cases you know that in the this 1 1 1 these are the atomic numbers, and here in protium the mass number is 1, for deuterium mass number is 2, and tritium mass number is 3. Okay, now here it is written that they have same number of protons but different number of neutrons in their atoms. Obviously you can, if you calculate the number of neutrons is equals to, here the mass number is 1, and because it is a neutral atom the atomic number is also 1, that means number of neutrons is equals to 0 here protium. In deuterium the number of neutrons is equals to 2 minus 1 equals to 1. Here the number of neutrons 3 minus 1 equals to 2. That means here it is 0, here it is 1, and here it is 2. That means the isotopes have same number of protons but they are different in the number of neutrons. Okay, similarly isobars. Isobars for the atoms of different elements having different atomic number, just opposite, different atomic number and same atomic masses are called isobars. One example is there, suppose you will take argon. Argon having atomic number 18, mass number is 40, and another element calcium having atomic number 20, mass number 40. So number of protons as well as different number of neutrons. Okay, that is why they have different number of mass number. Next is isotones. Isotones mean atoms having same number of neutrons are called isotones. Same number of neutrons. Okay. Suppose take an example: silicon, phosphorus, and sulfur. In silicon, atomic number is 14, phosphorus 15, and sulfur is 16. And atomic mass silicon is 30, phosphorus 31, and sulfur 32. If you calculate the number of neutrons here, it is 16. Okay. Atomic mass number minus number of protons, it is 16. For phosphorus is 16. That means 15 minus 31 minus 15, 16. And for sulfur also 32 minus 16, 16. That means these are the 3 elements having same number of neutrons, that is why they are isotones. Okay, and another term is that is your isoelectronic species. What do you mean by isoelectronic species? The chemical species in which the number of electrons is same are called isoelectronic species. This is your carbon monoxide is a heteronuclear molecule. Now N2 is a homonuclear molecule. N2 molecule. Carbon monoxide and nitrogen N2. In these two are having same number of electrons. How? See here, we know that carbon monoxide consists of by taking carbon dioxide, carbon atomic number 6, and oxygen atomic number 18. So number of electron is 6 here. Number of electron in oxygen is 8. So total number of electron in carbon monoxide is 14. Similarly, in nitrogen, one atomic number 7 means number of electron is also 7, and N2 means 7 plus 7 14. That means these are the two species having same number of electrons. So they are isoelectronic species. Okay.